Hello, glad you could join us. A reminder about using the bathroom pass. It's on the back wall. If you need to use it to go to the bathroom, that's fine. If you need to use it for something else, don't take that one. Come and ask me for a pass. So put your name and the time down if you're using the bathroom pass. I'd like to formally invite everyone to put their phone away. Hello? I do. Yeah, no problem. Bye. Jalen, your badge is at the office. Maybe they mean student ID. I'm not really sure. Actually, for the stuff that we're doing today, go ahead and get a calculator because it's simple math, but I don't want you to mess up on the simple math. So grab a calculator. You can grab a graphing one's fine. Especially if you were not your last class, you've got to pay attention today because you're a day behind. Some of you are 2 days behind. So definitely pay attention to the stuff that we're doing today. This is the last thing that we're learning before our quiz. So next class is a practice day, and then we have a quiz. Our notes are on the back of the notes that we took last class. So on the front, it was day 1. On the back, it's day 2. If you don't have them or you lost them, please come get one. Don't just sit here all class and not take notes. At the top, it says synthetic division can blank when used when the divisor is blank. So what we're going to put in the blank is synthetic division can only be used when the divisor is linear. That means it has to be something to the first power. So something linear, like a line y equals mx plus b, that x in that equation is to the first power. So a line has to be to the first power. There are 2 types of division that we're learning. We've got long division, which we did on the front. Synthetic division, you're probably going to like it. It's faster, it's easier, but it only works with linear terms. So it only works with linear terms. The things that we did on the front. So question or B on number 2 on the front, where we were dividing by x plus 3. So if you flip to the front, part B of question 2, where we were dividing by x plus 3, you could actually use synthetic division on that problem. And we're going to learn how to do, but you can use long division. You can do long division for everything. Synthetic division is faster. It's easier. I think you're going to like it, but it has to be a linear term. So this is very important. It can only be used if it's linear. But when it is linear, I assume you're going to use synthetic division because it's a little easier. Our first step, same thing with the front side of the notes, any kind of division, you have to make sure that you check for missing terms. So I'm going to give myself a note up at the top. You have to check for missing terms. It's the first thing that you should do on your homework. It's the first thing you should do when you get your quiz. We got to check for missing terms. To check for missing terms, you look at each part of the division problem. So I have my dividend and then my divisor. So I got my stuff and I'm dividing it by this. So I'm looking for missing terms. What that means is you scan through the problem and look for the highest degree. So the degree is just the exponent. So for this problem, the highest exponent that I have is a 3. So that means I start with 3 and I need to go 3, 2, 1, and then none. So you start with the highest exponent and you just count down. So when I look at this problem, I've got something to the 3rd power and then to the 1st power. So I go from 3 to 1 and I'm missing my 2nd power. So I need to put in there, this is a missing term, that I need to add a plus 0x squared. That's a missing term. So now I've got 3 and then 2 and then 1, but I'm missing the none. So to the none power. So I'm also going to add at the very end plus just a 0. It's a constant. So you have to start with the highest exponent and then count down. So for this one, I'm starting with 3. So I need 3, 2, 1, and then none. When I look at my divisor, what I'm dividing by, that is like an x to the 1st power. So I've got 1 and then I have none. So I'm good. I don't have to add any extra terms. While I'm doing it, I'm going to go ahead and look at this problem. Ooh, this is weird. What's weird? It's kind of not written in the right order. Typically, when we do these problems, you have the highest exponent and it's written on the left. So when it's written like this, that's standard form. This one is not standard form. There's a question on your quiz that is asking you, hey, put this in standard form. You have to be in standard form to do these problems. In standard form, so this is like a freebie question on the quiz. To put it in standard form, we just have to make sure that the highest exponent is first. So we've got a 3, a 2, a 1, and then a none. So we're not missing any terms. It's just in the wrong order. So to put it in standard form, just for that practice, let's go ahead and put it in standard form. Again, there is a question on your quiz and it's asking, it gives you something and it's mixed up like that. And it says, put it in standard form. So we just got to do the highest exponent and then we write it in decreasing order. The other part of that question is identifying the degree of something. So the degree of something is just the highest number for the exponent. So this one would be a 3rd degree because it's the highest exponent is a 3. I can't remember if part of the question is identifying how many terms, but if that is part of the question, you need to know that there's 1, 2, 3, 4 terms. Okay, so now we are ready. I guess you could give yourself a little note at the top. Not only do you have to check for missing terms, and this isn't very often, but you also make sure you're in standard form. That's not just for the stuff that we're doing today. That's for any division. So the stuff we did last class as well, but we didn't run across any problems in the examples, and I'm pretty sure there was none on the homework that you had to put it in standard form first. So synthetic division, what I'd like for you to do is put your pencil down and just watch me before you try and copy it down. Just watch and listen. So what I have to do for synthetic division is I'm going to write the stuff, but what I have to do first is figure out, so what I'm dividing by for this problem is x plus 3. When we were back solving and when we solved by factoring and we set this part equal to 0, we would figure out if we set that equal to 0 and we solved for x, what is x going to be equal to? It's -3, right? So it's just the sign is flipped. So when you do synthetic division, every time, whatever is in those parentheses, so it'll always, 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 always be x plus or minus something, because it has to be in that form to be able to even do it. So it'll be x plus or minus something. When it's in this form, to do synthetic division, you got to flip the sign when you use it. You don't have to do this work that I just did. You don't have to write out, oh, x is going to be equal to -3. You don't have to do all of this. You just need to know that whatever it is, you flip the sign. So we're not going to use 3. We're going to use -3. And when we set up the problem, we're going to have a -3 over here. And it's in like a little house by itself. Again, you don't have to start writing stuff down. I'm going to give you time to copy. I mainly want you to see what I'm doing. And then what I'm going to do is I'm going to write down the coefficients. So only the numbers. So I have a 3, 0, -27, 0. So I'm going to write down the numbers. 3, 0, -27, 0. I leave myself a little bit of space because it's not just one long number. And one way to know how many terms you're going to have, that is a third degree. Whatever your degree is, you'll have one more than that terms when you write down your synthetic division, because you've got to count your constant. So if I am a third degree, I will have 4 terms when I write out my synthetic division. So 1, 2, 3, 4. If you don't have 4 terms, then you missed something. I'm going to set it up like this. I'm going to leave myself a little bit of space because I'm going to put stuff in the middle as I write it down. Now, here's the part that I really want you to just watch. My first step every time is to drop it like it's hot. I got to drop that first term. From there, it goes kind of fast, so I want you to pay attention. So first step, drop it like it's hot. Then you're going to multiply, add, multiply, add, multiply, add. So what that means is 3 times -3, -9. 0 minus 9, -9. What's -9 times -3? Positive 27. So I got -27 plus 27, so I get 0. 0 times -3. 0. 0 plus 0 is 0. So I'm going to go through the steps again. First step, drop it like it's hot. 3 times -3, -9. 0 minus 9 is -9. Negative times a negative is a positive. 3 times 9 is 27. 27 minus 27 is 0. 0 times -3 is 0. 0 plus 0 is 0. So our first step, drop it like it's hot. Multiply, add, multiply, add, multiply, add. So I'm going to pause. I'm going to let you write this down. Ella, did you still have a question? Okay. So there's 3 steps to this problem. You drop, you multiply, and then you combine. I specifically said combine. I was going to put add, but I don't want you guys to be confused because sometimes you add a negative number. You're just combining like terms on the columns. So you drop, multiply, combine. And combine just means add or subtract. So we need to be able to write our answer. Our answer, here's what you have to start with. Your answer has to start every single time. You start by labeling the remainder. Okay, you have to start by labeling the remainder. So you will start with the remainder and we will build. So what that means is that the remainder is always going to happen in the very last column. So that is always going to represent my remainder. And then if we build, so it's going to go remainder. And then I have my x squared. Sorry. Stop. I forgot. It has to be constant. My constant x and then x squared. Maybe we should put label RC because you got to do remainder and then constant. The constant is just a number by itself. So when I go to put my answer now, my answer is 3x squared minus 9x. Do I have to put plus 0? No. Okay, so when we write our result is when you have this divided by this, our answer is equal to 3x squared minus 9x. Is x plus 3 a factor? Why do you say no? Okay, so the only thing that matters to know if it's a factor, and Andres is right, is the remainder 0. Yes. So is it a factor? Yes, because r is equal to 0. So that is why we're writing it every single time. It feels redundant that every time you answer the question, is it a factor? You need to tell me yes, because it's equal to 0, or no, because it's not equal to 0. That is how you answer that question. So yeah, it's a factor. It goes in there even. So let's do the next one. First thing that I want you to do, I'm going to do it up on the board. What I want you to do is just see if you can figure out what goes here and what the constant or the coefficients are to write along the top. See if you can set the problem up. So I'm going to, you see if you can set it up. Were you able to set it up correctly? Just with the constants, not constants, coefficients. Okay, again, if it is a third degree, you need to make sure you have 4 terms. So 1, 2, 3, 4 terms. When I set it up, I put an arrow in the very first column so it reminds me that my very first step is to drop it. So I've got to drop the first one. Did everybody remember that what goes in the little house is a positive one, not a negative one? Positive one because it's negative in the problem. There is a question on your quiz. So I try and give you guys as many hints as possible when you get to the quiz. I believe it or not, I really do want you guys to do well. There's a question on your quiz and it's about the setup of synthetic division. And so the question simply asks, how do you set this problem up? And so answer A, B, C, and D, it sets it up. Of course, they're going to put one where it's correct and has a positive one. They're also going to have an answer choice where it's a negative one. It could also have it to where these numbers are mixed up, something like that. But like, get that question right. Get it right. You don't even have to do any math. You just have to identify the setup. So our first step, drop it like it's hot. The very first column, it will always be the same. It just goes down. And then we need to multiply, add, subtract, multiply, add, subtract. So going straight down, I have a negative 1. Negative 1 times 1 is negative 1. 2 minus 1 is 1. So 1 times 1 is 1. Negative 3 plus 1 is negative 2. Negative 2 times 1 is negative 2. 5 minus 2 is 3. So I need to label R and C. I've got my remainder and my constant that I need to label. And then I start with X and then move up in degree. When I write my result, I can start with everything until I get to the constant. But for the remainder, the way we write the remainder is the exact same way that we wrote the remainder last class. You always, always, always have to put plus whatever the remainder is. But just like last class, the remainder has to be a fraction. So on the top, you put the remainder over whatever you're dividing by. And you write it just the way the problem wrote it. So if it's -1, you put -1. Is X minus 1 a factor? No, why? Right, the remainder is not equal to 0. Take the pass, write your name. We probably need to practice this a few more times, but do you feel sort of okay with synthetic division? We need to practice it, but hopefully we feel sort of okay with synthetic division. I've got a question to ask you. What is a 0? Do what? Oh, okay. So let me be more specific. So when we talked about when we did a when we were working with quadratics and we were finding zeros, we came up with, I think it was 4 different names that we can call a 0. They're your solutions. Yes, they're solutions. That's one of them. So I'll put that. What are other names for a 0? Yes, roots. There's a couple more. Yes, what'd you say? It's the x-intercept. Yes, a zero is a solution, it's a root, it's an x-intercept. It's basically where your graph crosses the x. So when you graph polynomials, what you get, and this is a very simplified version, but you get something that's like this. Polynomials are kind of weird, they're kind of crazy. So solutions, zeros, x-intercepts, if you divide something and it goes evenly, what it means is at that point, at that x value, you cross the x-axis. That's what it's saying. So we're kind of doing all of this stuff to lead into graphing these. So we know if it's a zero, that's where we put a point on the graph. So when we do this next section, and instead of just, is it a factor? I ask you in different ways. I ask you, is it a zero? Is it a root? Is it an x-intercept? It could also be, does it go through the point 0, 0? These things are kind of representing that idea that you cross the x-axis. So we've got another theorem. Don't be scared of theorems. Theorems are just fancy ways to say really complex stuff. So it says, if a polynomial, it's just called f of x, if polynomial f of x is divided by a linear term, then the remainder is, so it doesn't say anything about being a factor. So this is not talking about factors where the remainder has to be 0. It just says, if you are dividing something by a linear term, the remainder is f of whatever that value is. And that sounds confusing, but I'm going to show you what I mean. What that means, let's go back to these two examples, is that if I was dividing, I know what my remainder for both of these was. So it's saying, and looking at this one, so where it's already written as x minus, this just means that if I, whatever it was that you put in the house, whatever the value is that you put in the house. So for part A, if I did f of -3, the answer is the remainder. So for this one, it would be 0. For part B, f of whatever I put in the house, which was 1, the answer is my remainder, which is 3. So if you do f of whatever it is, the value you put in the house, the answer is always the remainder. So that answer is the remainder. That's what that remainder theorem says. That if you're doing synthetic division, f of whatever number is in that house is equal to the remainder. So whenever it's written like this, it already has the value changed. So you don't have to change the value when it's f of. So these problems say find f of, and it tells you the x value. Do not change the number when you put it in the house. The only time you change it is when it's written in parentheses or it's showing it as a division problem like this. Then you have to change the value when you put it in the house. So when we set these problems up, it says use synthetic division to find each function value. And then we're going to determine if it's a root or not. So when we set these up for the first one, the number that's in parentheses is the number that you put in the house. Same thing with B. The number that is in parentheses is the number that goes in the house. You don't change the value. To be able to do this, we've got to put the polynomial, we've got to check it. So what degree is this polynomial? What's the degree? What's the degree? What? Yeah, it's the highest exponent is a 5. So how many terms am I going to need if it's a 5th degree? One more than that. So I need 6. Because you always have to count the constant terms. So I'm going to have 5 x's and then a constant. So you're going to have 6. So as I go through, I definitely don't have 6. I have 3. So I'm missing terms. Okay, so I've got 5. Missing 4. So I need to give myself a little note. So I got plus 0x to the 4th power. It's hard to write that in there, but I'm missing that one. So now I'm going to start over. 5, 4, 3, 2. I'm missing the 1 and the none. So at the end, I'm going to have plus 0x and then plus my constant, which is 0. So now I need to make sure that I got everything. 5, 4, 3, 2, 1, none. I'm going to make sure I've got 6 terms. 1, 2, 3, 4, 5, 6. So now I've got everything there. So now I can set it up so that I can use synthetic division. So I'm going to write down all the coefficients into my problem and then the constant. Part B is using the exact same polynomial. So if you want to go ahead and set that one up, you can. So when I start my synthetic division, my first step, drop it like it's hot. So I get a 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 13 plus 1 would be negative 12. Negative 12 times 1 is negative 12. Do not trick yourself into thinking that that becomes 0. What is negative 12 minus 12? Negative 24. Negative 24 times 1 is negative 24. 0 minus 24. 24. Negative 24 times 1 is negative 24. 0 minus negative 24, or sorry, 0 minus 24 is negative 24. So now I can label R and C. I can start with my remainder and then my constant. Then next to the first, next to the second, next to the third, next to the fourth. One thing that you'll find is that whatever degree you started with, we started with the 5th degree. When you get your answer, it'll always be 1 less. So now I get x to the 4th because we just divided out 1x when we divided by a linear term. So to answer the question, which is actually up here, f of 1, what is it? Negative 24. It's always equal to the remainder. So is x equals 1? Is that a 0? No, because the remainder was not equal to 0. The next problem. So I'm going to not say it out loud, but I'm going to do it on the board. You guys do it on your paper. Let's make sure we get the same thing. So when you do this one, do you find is x equals 4, is that a root? Yes. Why? Because the remainder is equal to 0. But to answer the question, it's asking specifically about the remainder. The remainder is equal to 0. So f of 4 is 0. You have a question like this on your quiz. You have to do synthetic division. Any questions over A or B? Yes, sir. Here? Okay. So are you good up to here? Did you get a 3? Okay. So 3 times 4 is 12. Any other questions about A or B? Okay, let's try C and D on our own. So I'm going to do them on the board. You do them on your paper. As soon as I have them written down, I will advance the slide. Remember, they set up with the same constants and coefficients along the top. Yep. Mhm. So you guys are doing C and D on your own. Let's make sure we get the same answer.